Hello friends, welcome back to my channel and welcome to my discussion on networking techniques. I have uploaded a few videos on networking techniques, and today in this video I'll be talking about how to find a critical path when you have a list of project activities given to you. So you'll be having list of project activities. From that list, we will be first drawing the network diagram. We will be drawing the activity on arrow diagram, and then based on that diagram, we will be finding out the critical path for performing those activities. Okay, so critical path method, as you know, it is a technique or method used in project management for scheduling project activities. I have discussed many aspects of networking techniques in my previous videos. I will give link to those videos in the description section. You please do watch those videos. So this will be in this particular video. I'll be talking about critical path method, and specifically I'll be discussing a numerical where I will let you know how you can find the critical path if you have list of project activities given to you. So let us start our discussion. So let us first understand what is the numerical that is given to us. So we are supposed to find the critical path for performing following list of activities. So we have various activities. Now these activities, they are part of the entire project work, and you know work breakdown structure is used to divide the entire project work into small activities, and we are listing those kind of activities. So we will be noting down all activities. We will be noting down duration for each of the activity. You place note duration over here. Duration for each activity, it is given in weeks. And then uh, we are also given information about the predecessor activity for each of the activity that is listed in column number 1. So let us understand. So you have activity, first activity in the list is activity A. It is going to proceed for 35 months, and there is no any predecessor activity to this activity. Then you have activity B, which is going to proceed for 40 weeks, and the predecessor activity to this is activity A. Then you have activity C. The duration for this activity is 30 weeks, and predecessor activity is activity B. Then you have activity D. Duration is 20 weeks. Predecessor activity is A. Next activity is activity E. Duration is 50 weeks, and predecessor activity is activity D. Then activity F. Duration is again 50 weeks, and predecessor activity is activity C. Then you have activity G, which has a duration of 15 weeks, and predecessor activity to this is activity E. And last activity in the list is activity H, which has a duration of 16 weeks, and predecessor activities. There are two predecessor activities to this. These are F and G. So before you can start activity H, activities F and G have to be completed. Okay, so you have this list of activities given to you. Now let us understand how to prepare or how to draw the network diagram from this list, and once the network diagram is ready, how to draw or how to find out the critical path. Okay, now we have the list of project activities with us. Now let us learn how to use the list for preparing the network diagram or for drawing the network diagram. So what we will do, we will consider 4 activities first. First 4 activities we will deal with, and then remaining 4 activities we will use for drawing the network diagram. So let us understand. So again I have written all the first 4 activities. with all the information that is given to us, information about duration of each activity and predecessor activity. So activity A, B, C and D I have listed, their corresponding durations I have listed, and predecessor activities I have listed. Now let us start. Now if you look at the table, the first activity, that is activity A, it does not have any predecessor activity. So this is sufficient to conclude that A will be the first activity that is to be completed. So there will be a starting event for that activity, and there will be end event for that activity. Okay. So event 1 will be the start event for the first activity. First activity is activity A, and it is going to proceed for 35 weeks, and then it will get completed at event 2. So for activity A, 1 is the starting event and 2 is the end event. Okay. Then if you go back to the table, once A is completed, which other activity or activities you can start, it will be cleared from this table. Okay. So you see, when A is completed, you can start B, because predecessor activity to activity B is activity A, and at the same time you can start activity D, which also has A as the predecessor activity. That means you can start B and D once activity A has completed. Activity A has completed at event 2. So event 2 can be starting event for activity B and D. Event 2 will be the burst event from which two activities will be emerging. Which are those two activities? One is activity B and the other one is activity D. Okay. So first thing is activity B will start. It will proceed for 40 weeks and it will get completed at event 3. Then from the same event, that is from event 2, activity D will also start. It will proceed for 20 weeks and it will get completed at event 4. It will get completed at event 4. So from this particular you can say structure, you can understand that event 2 is acting as the burst event, where from where two activities are started. Two activities have been started, B and D. B is getting completed at event 3 and D is getting completed at event 4. Okay. After that you have activity C, which has a duration of 30 weeks and which can start once B is completed. So if you go back to the diagram, activity B is completed at event 3. So from event 3 you can start activity C. Activity C will proceed for 30 weeks and the activity will get completed at event 5. So you might have noticed I'm numbering the events as I draw those events. So the numbering is started at 1 and it will be ending at the maximum possible number in the network diagram. You will come to know about it. Okay, so in this way, for first 4 activities, we have drawn the portion of the network diagram. So, how event 2 is acting as a burst event, it is clear to you, because for activities B and D, the predecessor activity is activity E. So this tells you which event will be a burst event. Okay, so part of the network diagram is completed. Next, we will consider the remaining 4 activities, and based on the information for those activities, we will draw the network diagram. Now let us consider the remaining 4 activities. So we have covered 4 activities, that is activity A, B, C and D. Now let us talk about the remaining 4 activities. So remaining 4 activities, first let us list them. So you have activity E with its duration and predecessor activity. Then activity F, duration is 50 weeks, predecessor activity is activity C. Activity G, duration is 15 weeks, and the predecessor activity is activity E. And finally, the last activity in the list is activity H, which is going to proceed for 16 weeks. And there are two predecessor activities to this, that is activity F and G. So let us learn how to draw the remaining network diagram. Okay, so we have uh, activity C has completed at event 5. Activity C has completed at event 5, and from the list it is clear once activity C is completed, you can start activity F. Similarly, once activity D is completed, you can start activity E. That means activity E will start at event 4 and activity F will start at event 5. Okay. Next activity in the list is activity G. So activity G will be starting once activity E is getting completed. So after activity E gets completed, activity G will start, and finally activity H will be starting when both F and G are completed. So now let us represent this on the network diagram. So from activity D, after completing activity D at event 4, activity E is going to start and it will be proceeding for 50 weeks. So event 4 is the start event for activity E, and then activity E will be getting completed at event 6. Okay. So at event 5, now you can start activity F. But if you look at information for the last activity, that is activity H can only start if when both F and G are completed. So that means F and G, these two activities should complete at one event, and from that event, final activity, that is activity H, will start. So let us show this in the network diagram. So from after activity C, which completes at event 5, we are starting activity F. It is going to proceed for 50 weeks. Then, since F and G have to be completed so that you can start activity H, so it is necessary that activity F and G, they gets completed at a single event, and that event in this case is event 7. So when you are at event 7, both F and G are completed, and when F and G are completed, you can start the last activity in the list, that is activity H. So activity H is going to start at event 7. It is going to proceed for 16 weeks, and finally it will get completed at event 8. Okay. So in this way, we have considered all the activities in the list for drawing the network diagram. The diagram has started at event 1 and it has ended at event 8. The first event has the least number written on it, and the last event in the diagram has the highest number written for it. So this completes our drawing of the network diagram. So the information that is given in the list, we have shown it on the network diagram. We have pictorially represented information of project activities on the network diagram. Next, once the network diagram is ready, we will be doing calculations for earliest and latest event times, and then we will be calculating earliest and latest start time for each activities. We will be calculating slack, and from whatever results we will be getting, we will identify the critical path. Okay, now we have drawn the network diagram. So on this slide, I will show the diagram once again, and then we will use the diagram for finding various times. Okay, so I'm redrawing the network. So event 1, activity A, duration 35 weeks. Event 2, activity B, duration is 40 weeks, event 3, then activity C, duration 30 weeks, event 4, activity D, duration 20 weeks, event 5, activity E, duration 50 weeks, event 6, then you have activity F, duration 50 weeks, event 7, and activity G, duration 15 weeks, and finally you have activity H and event 8. Okay, so in this way I have just redrawn the network diagram. I have already explained how this network diagram is obtained. Now once you have this network diagram, let us do calculations for earliest and latest event times. So for that we will be doing forward pass calculation. During forward pass calculation, we will be calculating earliest event time for each of the event listed. And once you complete the forward pass calculation, we will be doing the backward pass calculation. Okay, so let us proceed. We will start at event 1. So we will draw a rectangular box. We will divide it into two parts. In the first part, we will be noting down earliest event time for event 1. And you have to remember, every time in a network diagram, for the first event, the earliest event time will be equal to 0. You are going to start at 0, which will be the earliest event time for the first event in the network diagram. Here event 1 is the first event, and for this first event the earliest event time will be 0. Okay, then you go to the next event, that is event 2. Again, for event 2, we will be noting down its earliest event time. Okay, how to get this? This is very simple. If you have the diagram, you can easily do that. In order to get earliest event time for event 2, you just add the duration of activity whose event is for which 2 is the head event. For example, over here for activity A, event 2 is the head event. Okay, so we are now calculating earliest event time for the head event. So what is that? That is equal to earliest event time for the tail event plus duration of the activity. So it will be simply 0 plus 35. That will give you earliest event time for event 2. Okay, now let us go to event 3. So for event 3, again we are going to note its earliest event time. So how are you going to calculate that? The earliest event time for event 3 will be equal to earliest event time for the previous event, that is event 2, plus duration of activity B. So it will be 35 plus 40, and that comes out to be 75. Similarly, for event 5, or let us first do it for event 4. So for event 4, how are you going to get the earliest event time? This will be earliest event time for the previous event, that is 75, plus the duration of the activity from which it is starting. So that will be 75 plus 30, and that comes out to be 105. So earliest event time for event 4 is equal to earliest event time for the previous event plus the duration of that activity, duration of the activity between those two events. So it is 75 plus 30, that is 105. Same calculations we will do for event 5. So now you can easily tell this will be 35, which is earliest event time for the previous event, plus duration of activity is 20. So it will be 35 plus 20, that is 55. Okay, then for event 6, the earliest event time will be earliest event time for event 5, that is 55, plus duration of activity E, that is 105. Now when you have done calculations for event 4 and event 6, for doing calculations for event 7, you can do it in two ways. You can calculate from event 4 or you can calculate from event 6. If you calculate from event 4, it will be 105 plus 50. And if you calculate from event 6, it will be 105 plus 15. So in one way you are getting 155 and in the other way you are getting it as 120. So out of this, which one to choose? I have already discussed about it in my previous videos. So when you are at such a point, you have to choose the maximum value. Event 7 is a merge event. So when you are at the merge event, you always use the path that gives maximum event time, maximum earliest event time. So in this case, in this particular case, from event 4 to event 7, we are getting the earliest event time as 155. 105 plus 50, that is the maximum. Here you are getting 120, so we are going to choose the maximum value. Therefore, for event 7, the earliest event time will be 155. Out of 155 and 120, we have chosen the maximum value, and the maximum value is 155. And finally, for event H, it is a very simple calculation. It is simply addition of 155 and 16. That is 155 earliest event time for event 7 plus duration of activity H, and that gives you 171. So that completes our forward pass calculations. Now we have arrived at the last event, so that ends our forward pass calculations. Now let us start backward pass calculations. Backward pass calculations are going to start at the last event and they will be getting completed at the first event, event 1. So direction for backward pass calculations, direction is from the last event to the first event. So let us understand. So as you know, we have to start at the last event, and for the last event, the earliest event time is equal to the latest event time. So for the last event, we will set the earliest event time is equal to the latest event time. So latest event time for event 8 is 171. Okay. Now when you proceed to the previous event, that is event 7, how are you going to do the calculation? It will be latest event time minus the activity duration. So over here it will be 171 minus 16. 171 minus 16 will give you latest event time for event 7. So that will be the, so 171 minus 16, it comes out to be 155. Okay. Then from event 7, if you go back to event 4, you'll be going in this way. And when you go from event 7 to event 6, you'll be following this path. So again, let us do the same calculations. Latest event time is 155. So 155 minus activity duration is 50, and that will give you latest event time for event 4, and that comes out to be 105. Same case over here for event 6. Latest event time for event 6 will be 155 minus 15, and that comes out to be 140. Okay. Then from event 6 or 4, if you consider event 4 and go back to event 3, so for event 3 the latest event time will be latest event time for event 4, that is 105 minus 30. And when you go back from event 6 to event 5, latest event time for event 5, it will be latest event time for 6, that is 140 minus 50. So these calculations will give you latest event times for event 3 and 5. So for event 5, it will be 140 minus 50, that comes out to be 90. And for event 3, it will be 75. How this is obtained? It is obtained by subtracting, or it is simply by doing this calculation. 105 minus 30, that comes out to be 75. Okay. Now next is you have to go from event 3 to event 2. and then from event 5 to event 2. You start at event 3, you are coming to event 2. Even if you start at event 5, you are coming to event 2. Now, two possible calculations you can do. Two possible values of latest event time you are going to get. Now, the question is which one to choose. Again, I have discussed this in my previous videos. When you are at such a point, you have to always choose during backward calculations. When you have arrived at a burst event, you choose the minimum value. Okay, now let us understand how this is. So if you go from event 3 to event 2, the calculation will be 75, that is latest event time for event 3 minus 40. That comes out to be 35. 75 minus 40 is 35. And if you go from event 5 to event 2, the calculation will be 90 minus 20, which comes out to be 70. So you have two options, 35 and 70. And as I said, for this particular case, you have to choose during backward calculation, you'll be choosing the minimum value. So minimum value out of 35 and 70 is 35, and we are going to choose that value. So it will be 35. Okay, so for event 2, the latest event time is 35. And finally, we have to go from event 2 to event 1. So again, it is a simple calculation. This will be latest event time for event 2 minus duration of activity A. So it will be 35 minus 35, that comes out to be 0. So for event 1, the latest event time is also, the earliest event time was 0, and now we have seen the latest event time is also 0. So in this way, by doing forward pass calculations, you will be calculating earliest event time for all the events, and by doing backward pass calculations, you will be calculating latest event times for all the events. So next, we will calculate slack for each event. Okay, now we have calculated earliest and latest event times for all the events. Now let us calculate slack values for each of the event. So for reference, I am taking the diagram from the previous slide. So you have the network diagram, and for each of the event, we have earliest and latest event times. Okay. Now we will prepare a small table. And what are we going to include in that table? We will write all the events. We will write earliest event time for all the events. We will write latest event times for all the events, and finally we will calculate slack for all the event. Okay, so what is the formula for calculating slack? Slack is latest event time minus earliest event time. That is entry in this column minus entry in this column. That will give us slack. So first, what I am going to do, I'll just list all the earliest and latest event times. For each of the event, I will list earliest and latest event times. So you have for event 1 it is 0, latest event time is 0. So slack is 0 minus 0, that comes out to be 0. For event 2, it is the earliest event time is 35, latest event time is 35, and slack is 35 minus 35, that is 0. Then for event 3, earliest event time is 75, latest event time is again 75, slack will be 75 minus 75, that comes out to be 0. For event 4, the earliest event time is 105 and latest event time is again 105. So slack for that event will also be 105 minus 105, that comes out to be 0. Then for event 5, the earliest event time is 55 and latest event time is 90. So for event 5, the slack will be 90 minus 55, that comes out to be 35. Okay. Then for event 6, the earliest event time is 105 and latest event time is 140. Therefore, slack for this will be 140 minus 105, that is 35. Then for event 7, the earliest event time is 155, latest event time is also 155, and therefore for event 7, the slack will be 0. And finally, for event 8, The earliest event time is 171. The latest event time is 171. Therefore, slack for event 8 is again 0. Okay. So in this way, we have the table ready with us. Now you just highlight those events for which slack is 0. So if you do that, first event 1, for event 1 the slack is 0, for event 2 the slack is 0, for event 3 slack is 0, for event 4 slack is 0. Then for 5 and 6 slack is not 0, so we are not going to highlight those two events. Uh, then event 7, for event 7 the slack is 0. So for event 7 we have highlighted, and finally 8 also has 0 slack, and therefore we have highlighted. Okay. So in this way, after doing preparing the table and by observing the table, we have this observation. What is the observation? For events 1, 2, 3, 4 and 8, event 1, 2, 3, 4, 7 is also included in that. I'll just note down. For event 7 also the slack is 0. So for event 1, 2, 3, 4, 7 and 8, what is the case? The case is earliest event time and latest event times are same. That means for all these events slack is 0, tau s is 0, or you can say tau is 0, tau or tau s, depends on you which notation you follow. So the slack for all these events is 0. So conclusion is, activities that connect all these events, they will fall on the critical path. They will fall on the critical path. All the activities which will connect to those events for which slack is 0, all those activities will fall on the critical path. So for this diagram, all these activities, which are the activities that will be lying, the critical path will be from event 1 to event 2 to event 3 to event 4 to event 7 and finally to event 8. Okay, so critical path will be from event 1, you start at event 1 to event 2 to event 3 to event 4 to event 7 and to event 8. So that will be the critical path. In this way, we have used values of slacks for all the events to identify the critical path. Now, next, what we will do, we will calculate earliest start time and latest start time for each of the activities. And from that information, we will again identify the critical path. We will prove that you get the same critical path. Okay, now let us calculate earliest start time and latest time start time for each of the activity. And based on the information, we will be finding or identifying the critical path. Okay, so again we will prepare a small table, and what are we going to include in that table? We will have activity, list of all the activities, then duration for each of the activity. We will calculate earliest start time for that activity, and then we will calculate latest start time for that activity. And what are the formulae that we are going to use for this? Earliest start time for an activity will be earliest event time for the tail event. So for example, for activity A, the tail event is event 1 and earliest start time for that is 0. So for activity A, the earliest start time will be 0. And latest start time for the activity will be latest event time for the head event minus activity duration. So for example, for activity A, the head event is 2, the latest event time for that is 35, and therefore the latest start time for activity A will be 35 minus duration of that activity, that is 35, which comes out to be 0. So let me first list all the activities. So we have activity A, duration 35, activity B 40, activity C 30, activity D 20, activity E 50, activity F 50, then activity G 15 and activity H 16. So I have written all the durations all the activities I have written, and then for each of each of those activities I have listed the durations. Now let us do this calculations for earliest start time. For activity A, earliest start time is earliest event time for the tail event. The tail event is 1, so earliest event time is 0. So for that it will be 0. Now latest start time will again be 0. How? Latest start time for activity A will be latest event time for head event. Head event is 2. Latest event time is 35. So it will be 35 minus 35, that comes out to be 0. Okay. Similarly for activity B, again for activity B, where is that activity? So activity B, tail event is 2 and earliest event time for that is 35. So that will be the earliest time for activity B. Latest start latest start time for the activity B. For activity B, how to get that? That is, the formula is latest event time for head event. For activity B, head event is 3, latest event time is 75, and so the latest start time for activity B will be 75 minus 40, and that comes out to be 35. So in this way, for each of the activity, you'll be getting earliest event time, earliest start time for the activity and latest start time for the activity. Okay, for activity C, it will be 75 and 105 minus 30. So both start and earliest and latest start time for activity C, it comes out to be 75. Similarly for activity D, again same calculations will give you these values. For activity E, you'll get these values. For activity F, you'll get these values. Similarly for activity G, you'll get these values. And lastly, for activity H, you'll again get the earliest event time and the latest event time. So once you have completed the table, next thing that you have to do is you have to highlight those activities for which the earliest start time is same as that of latest start time. So for activity A, this entries in the last two columns are same, so I have highlighted. For activity B, again same is the case, entries in the last two columns are same, highlighted. Activity C, entries in the last two columns are same, highlighted. Activity F, for D and F, for D and E, these are not same, so they will not be highlighted. So the next thing that is being highlighted is activity F, for which the earliest start time and latest start time are same is the case for activity H. So the conclusion is for all the highlighted activities, earliest start time is equal to latest start time, and all those activities for which this is satisfied. What is satisfied? Earliest start time is equal to latest start time. All those activities will fall on the critical path. Okay, so for activities A, B, C, F and H, for this 5 activities, what is the case? The case is earliest start time is equal to latest start time of the activity, and therefore all these activities, they will lie on the critical path. And if you look at the diagram, the critical path will be again the path which was shown in on the previous slide, same. If you look and follow this, you'll come to know that the critical path is from event 1 to event 2, from event 2 to event 3, from event 3 to event 4, from event 4 to event 5, from event 4 to event 7. Event 5 is not falling on the critical path. So from event 4 to event 7, and finally from event 7 to event 8. Okay. So in this way, for each of the activity in the network diagram, we have calculated earliest start time for the activity and latest start time for the activity. And then we have chosen those activities for which earliest start time is same as that of latest start time. Why we have chosen that? Because all these activities will be following on the critical path. And this, I have highlighted the critical path using the red color. Okay. Now on the next slide, what we will do, we will calculate floats for each of the activity. You know there are three types. You have total float, you have free float, and you have independent float. How to calculate them, what are this, I have already discussed in my previous videos. You please watch those videos. Okay, so on the next slide we will be doing that calculation, and we will show that for all those activities, for which all the three types of floats are zero, they will fall on the critical path. Okay, now on this slide finally we will calculate floats for all the activities, the three types: total float, free float and independent float. So for that I have prepared this table, and what are the entries in this table, let me first tell you. So we will be listing all the activities. We will be listing earliest start time for each of the activity. Then we will be listing latest start time for each of the activity. Then we will be noting down the head event for that, for each of the activity. And for all those head events we will be writing earliest event time and latest event time. Then we will be listing all tail events for the activity written over here, and for those activities again we will be listing earliest event time and latest event time. So from all this information we will be calculating total float, we will be calculating free float, and finally we will be calculating independent float. Okay, so which formula? Total float. How are you going to get total float? Total float. Total float is latest start time of the activity minus earliest start time of the activity. That is entry in this column minus entry in this column. Then how are you going to get free float? Free float will be earliest event time for the head event minus earliest event time for the tail event minus duration of the activity. So for head event, so the entry in this column minus entry in this column minus entry minus the duration of the activity. So duration of the activity I have not listed over here. So you can refer to the previous diagram. We have duration for each of the activity. Okay. And finally independent float is again earliest event time for the head event minus latest event time for the tail event and minus the duration of the activity. So in this way you can get all this three floats. So for example, for activity A, earliest start time is 0, latest start time is 0. Uh, then the head event is event 2. For event 2, earliest event time is 35, latest event time is 35. Tail event for activity A is 1, head earliest event time for that activity event is 0, latest event time is 0. So total float will be latest start time minus earliest start time, so that is 0. Free float is earliest event time for the head event 35 minus the earliest event time for the tail event, that is 0. So 35 minus 0, and duration of the activity is 35, so that free float also comes out to be 0. And finally you have independent float. For independent float you have this formula. So if you follow the formula, if you put all the values, you will come to know the independent float also comes out to be 0. Okay, so by using information of earliest and latest start times, event and tail, earliest event time and latest event time for head and tail events, and duration of the activity, you can get this three floats. So I have done calculations for all the activities. You please check those calculations, you follow those calculations and get the result. I'll simply show all the calculations. I have calculated three types of floats for all the activities. The formulae that I have used, I have shown over there. So you just see for all the activities, I'm now showing the three types, values of three types of floats. So you see, okay. So finally for activity H, after doing all the calculations, total float is 0, free float is 0, and again independent float is 0. So once the table is prepared, once the table is ready, you have to highlight those rows for which all the three floats are 0. So I'll highlight. First is for activity A, all three floats are 0. For activity B, all three floats are 0. For activity C, all the three floats are 0. Then for activity F, all three floats are 0. See, for activity D and E, even though free float and independent float are 0, total float is not 0. So those two activities I have not highlighted. And then finally for activity H, all the three floats are 0. That's why we have highlighted. Okay. So after the highlighting task is completed, we have to look at those highlighted activities. And what you can conclude from that, all those highlighted activities will be falling on the critical path. So the point is, all those activities for which all three floats are 0, all those activities, they will be falling on the critical path. Okay, so for activities A, B, C, F and H, what is the case? Total float is 0, free float is 0 and independent float is 0, and therefore these activities, they will lie on the critical path. And which is the critical path? 1 to 2, 2 to 3, 3 to 4, 4 to 7 and 7 to 8. So all these activities, they will fall on the critical path. So in this way, on this slide we have done how you can use values of floats to identify activities that are lying on the critical path. Finally, I'll just show you how the how to show. I'll show you the critical path, and once you have shown the critical path on the network diagram, you can also find out the project duration of the project. Okay, so activities A, B, C, F and H, they lie on the critical path. We have used three different methods to show that these activities are falling on the critical path. So what is the critical path? Critical path is event 1 to event 2, event 2 to event 3, event 3 to event 4, event 4 to event 7 and event 7 to event 8. So critical path is 1 to 2, 2 to 3, 3 to 4, 4 to 7 and 7 to 8. So once you have shown the critical path, you can also find out the project duration. So project duration, you simply add duration of the activities that are falling on the critical path. So it will be 35 plus 40 plus 30 plus 50 plus 16. So that many weeks will be the duration of the project duration for this particular list of project activities. So 35 plus 40 is how much? 75. 75 plus 30 is 105. 105 plus 50 is 155, and 155 plus 16 is 171. So 171 weeks will be needed to complete this particular project. Okay. So in this way, our calculations for identifying critical path gets completed. I hope you have understood the calculations. If you have any doubt, you please mention your doubts in the comment section. I will definitely answer to your questions. Please subscribe to my channel. Please hit the like button. Please hit the bell icon, and also tell your friends to subscribe to my channel. I will be uploading many videos related to chemical engineering. Thank you for being with me, and hope to see you very soon.